Hello, Mr. Richards here, and today's objective is to add linear expressions, so lesson 5-6. Our real-world link is, well, appropriately enough, homework. Luke has 20 math problems and 11 science questions for homework. Cameron has 23 math problems and 10 science questions for homework. The expression below represents the types of exercises that Luke has for homework. We have the 20 math problems and the 11 science questions. Now, complete the expression that represents the types of exercises that Cameron has for homework. And Cameron had 23 math problems and 10 science questions. Now, write an expression for the total number of math problems and science questions for both boys. Well, Luke had 20 math problems and Cameron had 23, so if we add the 20 with the 23, we would end up with 43 math questions. And if we added the 11 science questions from Luke and the 10 science questions from Cameron, our result there would be 21 science questions. Again, keeping them separate, we have 43 math problems and 21 science questions. Suppose Luke has X math problems and 5 science questions for homework, and Cameron has X math problems and 6 science questions. The algebra tiles below represent the total number of math problems and science questions for both boys. Write an expression in simplest form that represents the algebra tiles. Well, let's just make sure we understand what the tiles are meaning first here. We have X math problems for Luke, and that's there. 5 science questions, 1, 2, 3, 4, 5. Cameron has X math problems, well there's the X again, and 6 science, so 1, 2, 3, 4, 5, 6. Now, to write a combined expression, well let's look at our X's first. We have 1X here and 1X here, and 1 plus 1 is 2X. And when we look at just the ones, we have the 1, 2, 3, 4, 5 science questions, and the 1, 2, 3, 4, 5, 6. Well, we have 5, 6, 7, 8, 9, 10, 11, or 5 plus 6 is 11. And so to rewrite that to make sure we can see that, I tried to write it in the color, but not sure if that came across there. That's 2x plus 11. Now this isn't 13. This isn't 13x. It's simply 2x plus 11. Let's continue on. A linear expression is an algebraic expression in which the variable is raised to the first power. The table below gives some examples of expressions that are linear and some examples of expressions that are not linear. Well, we have our linear expressions here, 5x, that's to the first power. 3x plus 2 is certainly to the first power, as is x minus 7. But notice here we have 5x squared. Well, squared is not to the first power, it's to the second power. Cubed, 3x to the third power, that's not to the first power, nor is x to the fourth. So notice the difference. We're linear expressions, we just have the first power. Nonlinear expressions, well, second, third, fourth power are not, or non-linear expressions. Now we can add linear expressions with or without models, and sometimes you'll need to use what's called zero pairs as we cancel some things out. Our first example takes a look at how we would use algebra tiles or models. We have our 2x's here and our 1, 2, 3 there, our single x and our 1, 2, 3, 4 there. If you combine the like tiles or regroup them, so you have the 2x's here and then the 1x here, and the 3 1s and the 4 1s, 2x plus 1x became 3x, and 3 plus 4 became 7. So for those of us who are more visual learners, our model should help us see how these things get pieced together. Now number 2 is more of an algebraic way without models, where we arrange like terms in columns. So we have our 2x and our x here being like terms. So we line those up, 2x plus x, well 2x plus 1x is 3x. And negative 1 plus negative 5 is a negative 6. So 3x minus 6. Let's continue on to our examples. So the first one, 3x minus 5 plus 2x minus 3, let's try using algebra tiles. Let's try using models. So our 3x is 1, 2, 3 x's. Our minus 5 we can just write as, well, minus 1, negative 1, negative 1, negative 1. That's kind of hard to see there, but negative 1. Then plus another 2 x's, so 1, 2 x's. And then negative 3 would have a negative 1. Negative 1 is negative 2, and another negative 1 becomes negative 3. Now if I combine the like tiles here, combine my x's with my x's, I would have the 1, 2, 3 x's here with another 2 x's. And then I would have my negative 5, negative 1, negative 2, negative 3, negative 4, negative 5 with another 3 negatives, negative 1, negative 2, and negative 3. And so what do I have overall? I have 1, 2, 3, 4, 5 x's, so that would be 5x. And then I have 1, 2, 3, 4, 5, 6, 7, 8 negatives, so we could just write that as minus 8. Now, could you write it as, let's see, could you write that as 5x plus a negative 8? Yeah, that works too. I think this first way of 5x minus 8 is your most simplest way of writing that. So this is just 5x minus 8 is the best way to write that answer. Now, what if we do this without algebra tiles? We have 2x minus 4 plus 3x minus 7. So if we write this in columns, so let's write our 2x minus 4 plus, don't forget the plus, 3x minus 7. We have our like terms lined up. We have our x's lined up here. We have our constants, our terms without the variables, lined up here. So if we take our negative 4 plus a negative 7, negative 4 plus negative 7 is a negative 11, and 2x plus 3x is 5x. And that's all there is to that. That is simply 5x minus 11. Some of us may need the tiles to visualize what's going on, but ultimately I'm hoping all of us can get to this point where we can add and eventually subtract without the tiles. But it's going to depend on how comfortable you are with these as we continue on. Now there's one more way of writing these that might be useful for some of us. And if I rewrite this as 2x minus 4 plus 3x minus 7, what if I put boxes around my terms with x's? So 2x and plus 3x, and notice how I included the plus sign to the left of the 3x. And what if I circle my constants, my minus 4 and my minus 7? And once again, notice how I circled and included the term or the operation to the left of the number, the negative 4, negative 7. So this becomes horizontally 2x plus 3x, and then negative 4. You could write this as minus 7 or plus a negative 7. Either way works. And again, you get the same exact answer of 5x, because 2x plus 3x is 5x. And negative 4 plus negative 7 is a negative 11. So it's just another way. Some of us may prefer writing them in columns. Some of us may prefer writing them out horizontally and regrouping them that way. Again, knowing all three would be great, having all those tools in your arsenal. But I know that for some of us, one way may work best, this way may work best, or even this way may work. It's all going to be what you're most comfortable with, but keep practicing, and maybe all three will be comfortable as we continue on. So our examples here, 2x minus 3 plus negative x plus 4, and this is where we talk about zero pairs. So we have our 2x and then our negative 3, and we have our negative x and our plus 4. And notice they put the negatives in red here. And we have our 2x's and our negative x, and positive x and the negative x canceled. So you're just left with 1x. And we had our 4 positives and our 3 negatives, and 3 of those canceled out, so we're just left with 1 positive. So basically 2x minus 3 plus negative x plus 4 just simplified down to x plus 1. Now it is possible that we're going to be using the distributive property here as well. So we would have to distribute the 2 to the x and the 3 to get 2x plus 6 there. Now notice it did not get distributed to the 3x and the 1 because we're not multiplying the 2 by the 3x plus the 1, we're just multiplying it by the x plus 3. And then we regroup the 2x plus 3x to get 5x, and the 6 plus the 1 to get 7, and we got 5x plus 7. Now here we had to use distributive property in example 5, involving some more negative numbers, where 5 times x minus 4 became 5x minus 20. And then 5x plus 2x was 7x. Negative 20 plus negative 7 was negative 27. And again, models may help with us. Writing them in columns may help. And we have plenty of examples here to try next. So add, use models if needed. X minus 1 plus 2x plus 3. And let's try without a model here. Let's line these up. X minus 1 plus 2x plus 3. Well, here's how we need to see this. Negative 1 plus a positive 3. Again, negative 1 plus a positive 3. What is negative 1 plus 3 but a positive 2? And x plus 2x, remember, this is 1x. We rarely ever write the coefficient of 1 because it's assumed that it's 1x, but if you need to write that as 1x to help remember that as you add or subtract these, then please do. 1x plus 2x is 3x. And so our simplified answer here is 3x plus 2. What if we write this next one in columns? We would have x minus 4 plus negative 2x plus 1. Well, once again, negative 4 plus 1 is a negative 3. And x plus a negative 2x is a negative 1x. So we have negative 1x minus 3. Now, just like in C, where we rarely include the positive 1 with our x as a coefficient, the most simplified way to write this is just simply negative x minus 3. And those are our answers for C and D. And now we get to our distributive property questions of adding linear expressions. So we're going to have 6 times the quantity x plus 7 plus 6, or x plus 3, excuse me. So if we distribute this 6 to the x and to the plus 7, we would have 6x, because 6 times x is 6x, plus 6 times 7 is a plus 42. And then we still have our plus x plus 3. Again, notice we only distributed the 6 to the term x plus 7. We don't have the 6 outside the x plus 3, so we're not going to distribute to those. And now if we write this in our columns, we would have 6x plus 42, and then plus x plus 3. And so 42 plus 3 is a positive 45, and 6x plus 1x is 7x. So we have a simplified answer of 7x plus 45. What about f? Well, we have 12x plus 19, but then we have plus the quantity 2 times x minus 10. So we do need to distribute here with our 2 to the x and the negative 10. So we have here 2 times x minus 2 times 10. And actually that's a 2 times 10. Included this negative or the subtraction there. So we would have 12x plus 19, and 2 times x is a plus 2x, and 2 times negative 10 is just a minus 20, negative 20. And if we write this in our columns again, we have 12x plus 19 plus 2x minus 20. And so now we have 19 plus a negative 20. Well, 19 plus negative 20 is negative 1, so minus 1. And 12x plus 2x is 14x. So we have a simplified answer of 14x minus 1. So now as we look to add linear expressions in geometry problems, write a linear expression in simplest form to represent the perimeter of the triangle. Then find the perimeter if the value of x is 5 centimeters. Well, notice we have our 3x minus 3 plus 2x plus 9 plus 5x. Those are our terms. So we have 3x minus 3 plus 2x plus 9 plus 5x, because remember, to find perimeter, we simply add up all the sides. Now what they did here was they regrouped them like we practiced in one of the questions horizontally, the 3x, the 2x, the 5x, and the negative 3 plus 9 to get 10x plus 6 as your expression. Then if x is 5, you put in 5 for the x to get 10 times 5 plus 6. 10 times 5 is 50, plus 6 is 56 centimeters. And now we get the chance to practice that next. A rectangle has side lengths of x plus 4 feet and 2x minus 2 feet. Write a linear expression in simplest form to represent the perimeter. Find the perimeter if the value of x is 7 feet. Well, I know I like to see pictures. I might not be good at drawing them, but I like to see them at least. So we have the side lengths of a rectangle of x plus 4 and 2x minus 2 feet. Now, perimeter for a rectangle, two ways of doing this. You could just kind of plug and chug and know, okay, well, I have 2x minus 2 plus x plus 4 as two of my sides, plus 2x minus 2 plus, that's not a very good plus there, plus is still pretty bad, but plus x plus 4. I think that's a lot of work and a lot of more terms to combine. You could do it that way, because remember, a rectangle has 4 sides, so you'd have to add all 4 of them up. Or you could use the formula for the perimeter of a rectangle. Perimeter equals 2 times the length plus 2 times the width. Now, either way you do it, you'd get to the same answer. Let's try this formula way, because I think in the long run it's more efficient. So perimeter would equal 2 times, and just pick one of the sides for length. We'll go x plus 4, and then plus 2 times 2x minus 2. Now when we distribute this, perimeter equals 2 times x is 2x, 2 times 4 is plus 8, 2 times 2x is 4x, and 2 times negative 2 is a minus 4. Again, just to review that, 2 times x was 2x, 2 times a positive 4 is a positive 8, 2 times this 2x is 4x, and 2 times negative 2 is a negative 4. Now if we regroup these, we would have 2x plus 8, and then plus 4x minus 4. Well, 8 plus a negative 4 is 4. And 2x plus 4x is 6x plus 4. And that's our simplified expression, 6x plus 4 feet. And now if the value of x is 7 feet, we could say, okay, 6x plus 4. And again, I know here that x is 7 feet. So coming down here, x is going to be 7. So all I need to do is substitute in that 7 for x. 6 times 7 plus 4. And 6 times 7 is 42. Plus 4 is 46 feet. So we have our expression, 6x plus 4 feet. And we have our simplified answer of 46 feet. Now, again, for those of you who may have struggled here with the distributive property, you could add your 2x plus x, 3x, plus 2x, 5x, plus x to get 6x. And you could do your negative 2 plus 4 is positive 2, plus negative 2 is, well, 0, plus 4 is 4 to get your 6x plus 4 that way. Nothing wrong with that, just preferred to show you the distributive property way. But as long as you're showing work and it's making sense and you're getting it right or learning from your mistakes, then you're doing just fine. That's it for this lesson. Good luck.